Hi, my name is Kat Riley, and today we're going to be talking about deep sea circulation and why it's important. So, deep sea circulation is the movement of large water masses around our oceans, and it has two driving forces: temperature and salinity. And density variations, driven by changes in temperature and salinity, are what cause these large water masses to move around. So, as temperature decreases and salinity increases, density also increases. And this graph is a good visual representation of that relationship. Those diagonal and curved lines are lines of density. And where the red star is, you can see the lowest density, which is where temperature is highest and salinity is lowest. And where the blue star is where there's the highest density, where salinity is the highest and temperature is the lowest. This relationship between temperature and salinity is also why deep sea circulation is sometimes called thermohaline circulation. Thermo meaning temperature, and haline meaning salt. Now there's a general pattern of deep sea circulation, and we'll go through it step by step, starting with the little yellow star and the red line coming out of it. Now this red line is actually a surface current commonly known to us as the Gulf Stream. And the Gulf Stream brings warm tropical waters from lower latitudes up to higher latitudes. And as the Gulf Stream approaches the Arctic, it starts to cool, and then as sea ice forms, it increases the salinity of the water. Because of this, the water starts to sink, which is also known as downwelling, to the bottom of the Atlantic Ocean. Once there, it progresses down to the lower latitudes, and it eventually merges with the Antarctic bottom waters. And then from there, these two bottom waters circumnavigate the Antarctic together. The deep water then flows north to the areas of lower density, like the Pacific and Indian Oceans, where it eventually surfaces or upwells. The warmer surface waters then find their way back to the Gulf Stream, and the process starts again. So on this map, it doesn't follow exactly the path I said, but I just kind of summarized it. But you get the gist that the red lines are the warmer surface currents, and the blue lines are the cold bottom waters. So what's so important about all of that? Upwelling. And upwelling, like I said, is when the cold bottom water is brought up to the surface. So as cold bottom waters navigate the globe, they collect nutrients like carbon, nitrogen, and silica as they settle to the bottom of the ocean. So when plant matter starts to decay, or animals, or fecal matter, those nutrients settle down to the bottom, and then that's when the cold bottom waters pick them up and carry them with them. So then, when the cold bottom waters upwell, they bring up all of those nutrients to the surface. And this invites a lot of primary producers, sort of the OGs of the food chain, no big deal, like plankton and algae to feed on them. And here are some examples of those. This is these are diatoms. That's a copepod, a dinoflagellate, and plankton. And these primary producers are an important food source to a lot of other animals. For example, whales, like baleen whales, jellyfish, and even some species of fish. So I'll leave you with this question that we can talk about in class. How could an increase in global temperatures affect this process?